To begin, we must set this equation equal to 0. To set it equal to 0, we must subtract 5 from both sides. We now are left with 2w squared plus w minus 5 is equal to 0. Remember, we use the quadratic formula when we cannot solve by factoring. The quadratic formula says x is equal to, or in this case, w is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. We're going to write out what each value is. Alright, our a is 2, our b is 1, and our c here is negative 5. So now we can take that information and substitute it into our formula. W is going to be equal to the opposite of b. So the opposite of 1 is negative 1, plus or minus the square root of b squared. So b is 1, so 1 squared, minus 4 times a, which is 2, times c, which is negative 5. All divided by 2 times a, which is 2. We now have w is equal to negative 1 plus or minus the square root of 1 squared is 1. And then we have negative 4 times 2, which is negative 8. Negative 8 times negative 5 is positive 40. So plus 40, all divided by 2 times 2, which is 4. We now have w is equal to negative 1 plus or minus the square root of 41 divided by 4. We can break this out to solve for the plus or the plus and the minus. So w is equal to negative 1 plus the square root of 41 divided by 4, or w is equal to negative 1 minus the square root of 41 divided by 4. When we take the square root of 41 and round it to the nearest hundredth, and then add that to negative 1 and divide by 4, we end up with a solution of approximately 1 in 35 hundredths. When we take the square root of 41, alright, and we do 1 minus that, and then we divide it by 4, we end up with approximately, or w approximately equaling, for the negative piece here, negative 1 in 85 hundredths. If we were to write this out as a solution set, it'd be negative 1 in 85 hundredths and 1 in 35 hundredths.